Okay, so I think we can start. Hi, everyone, and welcome to our webinar today. We will be discussing a significant update from Scout called Smart Search. It's our new AI-powered semantic search that helps you find exactly what you need without any confusion. And today we'll see it in action, and I let Dr. Peter Walde, MAPEGY CEO, speak in just a second. He will be joined by Dr. Matthias Blauer, our esteemed data scientist, and Christoph Jenke and Ashar Ahmad, MAPEGY experts. Our team drafted a white paper about smart search, and I'm happy to share it with you in the chat so you can have it available to consult it at any time. And on behalf of the MAPEGY team, I'd like to say that we are very excited to share our learnings and answer all your questions. We already have some comments. We got some questions already in the past days. So if you have any other questions, please feel free to drop them in the chat. I'll keep an eye on it, and we'll have dedicated Q&A sessions at the end of each panel. So now I think we can get started. Peter, please, the stage is yours.
Perfect. Do you see me as well, especially also my presentation? Everything good? Perfect.
Yes.
Okay. Hello, my name is Peter Walde. I'm CEO and founder of MAPEGY, and I don't know how many people are there now since I'm kind of blind, but I know that there were about 40 participants that registered from 20 different enterprises. So I'm really happy that you all join and listen to us, especially what we have to present today. Probably likely only people from Europe because of the time zone, but I promise that we can and will also have more of these webinars. Especially, of course, you can also reach out to all our key account managers, since that's today a very specially focused only on customers webinar. So why are we inviting to this webinar? We have big news to announce, and I'm thrilled to announce a game-changing addition to our innovation intelligence platform, Scout. We want to announce the new feature, which is called semantic search, known as, or we call it smart search, which in my opinion is not just an upgrade, it is more. In our presentation today, highlights are we are going to have a short introduction by our chief data scientist, as Alessia has already said, Professor Dr. Matthias Blauer, and also myself. Then, of course, it is all about the product. It is all about the smart search. So we want to see, and we are going to test smart search in action based on 3 different use cases. I'm also happy that Ashar joined us. So likely since he was sick, unfortunately. So let's see if he can have all 3 use cases, or if we are only going to focus on chemicals and automotive use case. We're going to decide based on time. And then, of course, it is a open presentation and discussion here today. So obviously anyone can ask anything. As Alessia said already, we have the chat open here. So directly, please don't be shy, ask any questions, since of course it is going to be also, it is very technical as well. And smart search or semantic search is something new. So I'm really looking forward to an open Q&A. And of course, we are also going to have a sneak peek to the roadmap, to what is going to happen next with our product. Because smart search is something which is really, in my opinion, something very big. It is not only currently what we are going to present to you. It is not only going to be the smart search for documents in the long run, because the first beta and the release that we shared with you is focusing on documents and publication panels only, which we are going to show you. But the smart search, of course, will also going to expand to all other panels throughout the whole product. And it has the opportunity and chance also to make the UX and the product way, way, way simpler. So we are also going to refresh the user experience, the look and user flow of the platform, which I'm going to show you in a sneak peek at the end of the webinar. So it is a huge progress from our perspective, and I'm very happy about that. And it is also huge for us because more than 20 experts from our product team have been working tirelessly in the back end for years now I have quickly calculated in this morning that there were almost 100 hours, 100,000 hours being invested, and also several million in budget, so that we can discuss this little box that you're going to see later today, so that we can discuss it here today. So now everything finally comes to light, and I promise changes and improvements will be much, much more visible and faster now. So again, big shout out not only to you customers, of course, because without you it would have been not possible, but especially also to the team behind the scenes that is shown here, led by Matthias, our chief data scientist, whom I want to hand over now the presentation to give you guys a short introduction.
Okay, thank you very much, Peter. So my name is Matthias Plaue, and I'd like to go a little bit into detail into the why and the how of what we call the smart search, a new feature in MAPEGY Scout. So when it comes to the motivation of why we decided that we would complement the MAPEGY Scout Query Builder with a new search functionality, I demonstrate this by showing you on the left-hand side a typical query that a patent analyst would use in order to retrieve relevant documents in the field of ultrasonic sensor systems for automobiles. And as you can see, the query is quite long, it is quite complex. It also includes some features that only certain experts for search functionalities and information retrieval are familiar with, such as, for example, wildcards, in order to find the word stems of certain phrases. You can see patent classes being searched for. So in order to apply such a complex lexical expert query, you would have to invest a lot of time and a lot of domain knowledge and a lot of expert knowledge in terms of information retrieval. Now, wouldn't it be nice if we could just enter the phrase that I'm looking for? In this case, ultrasonic sensor systems for automobiles. And the answer is yes, you can, but you need different technology for that. So what we are aiming for is, instead of looking for the word ultrasonic sensor system, we want the system, the search engine itself, to understand the query, the meaning of the query, which is commonly known as a semantic search, and we call it a smart search in MAPEGY Scout. Next slide, please. So what we want to do from a more high level is, as I said, the words, the phrases, the sentences, which itself are just strings of letters to any computer, should be replaced by a different representation of the data, which encodes the meaning of the text, of the content, which in case of MAPEGY Scout are news articles, scientific documents like research papers or patent documents or technical standards. And here you can see graphically the difference between the two approaches. So if I have just words, I could, as a search expert, for example, search for sensor, which would give me a lot of different types of sensors, like vibration sensors, infrared sensors, but it would also yield a result like sensor fusion, which is not a particular type of sensor. So it's in a different area of the semantic field. On the right-hand side, you see a graphical representation that uses a different type of underlying abstract representation of the content, which are called word or sentence embeddings. And here you can see that all the types of sensors are tightly clustered, whereas sensor fusion has been correctly identified as something with a different meaning altogether. Next slide, please. So as to how does it actually work in technical terms, if the user enters a search query, like for example, ultrasonic sensor systems for automobiles, the system, the MAPEGY system will send that query to a large language model, which is a pre-trained artificial neural network. And it is not interested actually in the output. If, for example, you would enter such a query into ChatGPT, ChatGPT would also send this query to a large language model and would use the output to generate basically random text. Of course, it's still structured, but it's still basically random. What we are interested in rather is actually the hidden values of the large language models. If you will, what we want to look for is, if you want to keep with the biological metaphor, we want to do a brain scan of the neural network and see what neurons are activated by that particular kind of query. The result is quite, if you look at it, it is not very impressive. It's just a long string of numbers. It's the query vector, but that is the embedding. That embedding encodes all of the meanings that this particular user query can have. And that vector is what is sent finally to the MAPEGY innovation graph database. And we compare that query vector with the vectors that we have computed on integration time, computed from the documents that have been captured from various data sources. And the documents that are closest to the query vector are the ones that you see in the result table. And the idea is that the meaning represented numerically by the activations of the hidden layers of the neural network give a good enough representation of the meaning as to find similar and relevant documents to what the user is looking for. Next slide, please. Now, I've already mentioned ChatGPT, and ChatGPT famously also uses large language models. The latest that they have published is GPT-4o, which is a even multimodal language model, so it's also capable to understand structured information and also images. And maybe some of you ask themselves, well, I'm looking for trustworthy content, and ChatGPT is also famously known for hallucinating. So I have a short example here. If you enter in ChatGPT the task very shortly, explain the application of an ultrasonic transducer in the making of French toast, it will tell you how that works. An ultrasonic transducer can be used in the making of French toast to improve the infusion of flavors and ensure even soaking of the bread. By using ultrasonic waves, the transducer creates microscopic bubbles and vibrations that help the egg mixture penetrate the bread more thoroughly and quickly, etc. So this is, of course, completely wrong and fabricated. And this is because we use the large language model in that case in order to generate text. And this produces plausible, but sometimes very wrong content. We don't use the large language model to generate text, but rather to identify the relevant content in our database. So what you see in MAPEGY Scout is not, and I want to stress this very thoroughly, it is not randomly generated text like from ChatGPT, but it is the actual raw data that we capture from our data sources, which are reputed data sources like the European Patent Office, like scientific publishers, etc. So these data have not been manipulated in any way. So we use the large language model to identify those data points, but not generate them. And this concludes my part of the presentation. And I will hand over to Peter now.
Thank you, Matthias, for the intro. I want to conclude with looking at the use cases and the different benchmarks we did with the semantic search with our smart search, since of course we didn't just want to publish it. There was a lot of work, as I said already, in the backend done, but of course we need to test different use cases to see how they work and if there is really improvement. Of course, it should be very systematic, since we need to build, measure, learn, and we are going to do so during for the next weeks, months, and quarters. But again, we needed to do, and we did a systematic benchmark. Of course, we did already way more tests, but that was a systematic benchmark based on 32 different topics representing all 7, 8 industries or sectors that we support. And again, the goal was here to compare our lexical, or how we call it, expert search, with the semantic search, how we call it, smart search, based on 4 different criteria: ease of use, runtime, comprehensiveness, and relevance. And which got clear is that the smart search, of course, as we expected already, is way easier to use. As you see here, we asked the experts, was it difficult to build it up, the search query? Was it easy, or was it medium? And for the smart search, of course, 31 of 32 use cases were very easy to use and build a query for. Whereas for the expert search, as you can expect, of course, sometimes it can be very difficult to build up complex, relevant queries, which you're later going to see in the use cases as well. Of course, runtime, that was more questioned by feeling. Here in this case, of course, we also tested it automatically, but in this case, it was really looking at the user flow, asking experts how did they feel about using it. Then most important are the 2 indicators, comprehensiveness and relevance. Results for the smart search were mostly very comprehensive compared to, as you see here on the right table, compared to the expert search, especially also for a lot of use cases. Actually, there were no results shown with the expert search, because of course it is directly looking at the keywords that you type in, and if keywords in these publications don't appear, of course there are not going to be any publications in this context on this regards. And last but not least, relevance. The relevance of results was slightly, but definitely higher for the smart search compared to expert search. A bit simpler representation here. As you see, for most of the topics, the smart search outperforms the expert search. But again, it is probably very abstract, and this is why we have prepared 3 different use cases where we really want to look into the searches and also show you the difference right away. So we've prepared, as I said, 3 case studies. One is in the chemical sectors. The question here is fused granular fabrication. The second is going to be Botnetze, which Christoph is going to present and discuss, and then we're going to see how much time we have. Ashar has also prepared a short use case in the context of manufacturing about hydrogen aircraft. The first case study is on me, and I've prepared this case study or the test already 3 months ago, and I back then prepared a short video which I want to play now, and then we are directly going to dive into the live system using the smart search. But let me first play the case study here on fused granular fabrication. Alessia, just quickly tell me if the video sound is on, just to be sure. Hello, my name is Peter Balde.
Yes.
And CEO.
Yes.
I want to tell you a use case that I experienced 3 months ago using our lexical search means of Boolean operators for a specific search I had in mind. I was asked, I'm part of a jury of the startup Growth Garage, which is run by one of our esteemed customers, Mitsubishi Chemical Group. And they have a Growth Garage, which is kind of working as an open innovation hub where the Mitsubishi Chemical Group reaches out once a quarter to new innovations out there worldwide. And as I said, I'm part of this program, at least program's jury. Here, there's a esteemed group of experts, managers, and in this time for the program, it's running already since 2 years, and I think it was now the 6th or 7th challenge. And this challenge was about 3D printing, also with a focus on fused granular fabrication. And I was asked to hold a keynote before the official winner announcement. So I knew that there was one winner, a few sub-winners, but there were more than 5,100 applications. So of course I needed to know what I'm talking about. I need to know what all 3D printing or fused granulate fabrication is all about. So I needed to dive into it, and I started to search with Scout. The topic is fused granulate fabrication, and at first what appeared to me, oh, fused filament fabrication, that's obviously supported here and it's related, let's look into it. And I was very happy, that's probably what it is all about. Found, okay, a lot of publications, news, research, and patents. And I was somehow very quickly happy, but then I found out, since I kind of dived more deep into publications, and I figured out, oh, fused filament fabrication is exactly the opposite. I mean, it's not using pellets or granular things, but filaments. So that's exactly not what I should have, what the challenge is all about. And then I said, okay, I need to dive into, need to understand it even better. And I started to search on Wikipedia for fused granular fabrication, and I again found fused filament fabrication as the first topic here, or fused deposition modeling, which is related, but definitely not fused granular fabrication. And even looking at 3D printing per se, I found only out that, okay, there are these different applications and methods, and fused granular fabrication is part of material extrusion, which is explicitly shown here in this context. So then it went into the 6th or 7th document shown here by Google, 3D printing processes. And then I looked into it, okay, material extrusion, but here again, nothing is mentioned. Fused granular fabrication is not mentioned here in this scientifically, whatever proven document, Wikipedia. And I was very frustrated. So I looked into, again, Google, I went into these 5th and 6th publication you provided, which really where I really dived into it and understood, okay, fused filament fabrication is exactly opposite to granular fabrication. Looked into videos, I kind of got different keywords, pellet printing, fused granulate fabrication or granular fabrication. I understood, okay, that's also particle fabrication, could be the same, could be the synonym. So step by step, after 1 hour about reading, diving in, reading again, exploring, understanding, I got into this broader search query. Using this search query, I figured out, okay, it's definitely not as many documents as fused filament fabrication, but at least, I mean, I got a lot of web publications, but I got, let's see, news still calculating. Let's start with research. I got 35 research publications, which were pretty precise. And I found high precision here, 41 press publications in this very specific context. Only 3 patents, no research projects, grants, no standards. So I was like, still weird. That's not possible. But fair enough. I mean, it's precise. It's probably what I have, right? Or what is out there. But somehow knowing that there are 50 applicants, more than 100 players out there who only applied for this program, it was off. So what I thought, I need to go diving into it again and going to probably just start a new search, which I did then. Duplicate, which I did. And here, and I started searching only for additive manufacturing. Yes, here we go. And a new 3D printing and rapid prototyping is probably not shown here, is a synonym for that. And then I connected it with everything which I found there, pellets, granular, or granulate. But again, I always needed to type in all these different synonyms, yeah, or particle, that was it. Or particle could be also written like that. That's what it is. What is part of the lexical search. You need to be very precise here to kind of really shoot straight to what you want. And of course, here I found a lot of standards research projects and patents, of course. But they, again, now the recall was very high, yeah? But the precision was not really high. So I had to kind of decide, either I go with the very precise but not high recall search, or I go with the very broad recall but little precision search. But somehow it was all off. I was not really clear in the end. I chose the very precise, rather have precise search, and all results that are shown are relevant than like having a lot of rotten apples, you could say, in your search and analysis, right? But it altogether took me 1.5 hours, also 2 hours probably.
Yes, and it took me long, as I said in the video 2 months, 3 months ago. And now I want to, that was based on lexical search, or how we call it, expert search. And now I want to jump directly in my use case for fused granular fabrication to our new smart search. And it's very simple. If I had this engine 3-4 months ago, we've just typed in what the topic is about or was about, fused granular, or it doesn't matter if I type in granular or granulate fabrication, and start searching. And I'm directly going to get relevant web news, which are 100% precise. Way more, as well as I found with the expert search or lexical search. Also here directly, the first result is, of course, the challenge that I was talking about. All results are correct, precise. A lot of research publications. As you remember, in the special search, there were 3 patents only. Here I found definitely relevant patents and more as well. Even projects that are connected to the same topic. As you see here, it's even not mentioned if fused granular or granulate fabrications are not mentioned here directly, but it talks about 3D printing, and it is definitely in the same topic. That's what I looked into it already. So as you remember, there were no standards found in this case. Based on the semantic search, there are standards. In this case, although it is, again, fused filament fabrication, which is kind of likely a competition to the technology, but still it is a standard related to the same technology. So it is way more comprehensive, also way more precise. And as you see, it took me like 10 seconds. Of course, I need to read and analyze the results of these publications. That, of course, I need to do and take the time. But the search itself is way more fun. And of course, yeah, less frustrating, way more fun, and way more easy. Summing up, that was a use case for fused granulate fabrication. And I'm asking myself, shall we do a short QA? Are there already any questions in this regard? Otherwise, I would happily hand over to Christoph for the second use case.
Yes, we just got one question.
Mm-hmm.
Yeah. Is it possible to include a not operator in the smart search? For example, not filament.
Love to hand over to Matthias in this case.
That's unfortunately not possible. But what you could try is simply tell the algorithm to exclude whatever you want to exclude. So, for example, give me all ultrasonic sensors for automobiles, excluding those for trucks. And this might already give you what you want.
Thank you. Any more questions? Then I'm happily handing over.
No, we have
Yeah.
one more question. Is it possible to search, for example, for terms SLS free?
I don't get it now. SLS free, what is it about? But probably others, Matthias, I don't know, you understand probably.
I don't know what that is either.
I mean XX free.
Hello, this question is from me. I mean searching for terms, something free, something, for example, when I'm interested for some technology which doesn't contain something other. So if it is possible, if system can distinguish that I want to omit these terms.
Mm-hmm.
Thank you.
Okay, that is basically the question regarding the not operator. So unfortunately, that is not possible in a strict sense, but you can try and tell the system to exclude the terms. So how Smart Search works is it interprets a natural language, natural description of what you're looking for. So if you want to exclude something, just include it in your query as an additional explanation of what you're looking for.
Yeah, thank you for these questions. Since I see this is also one of the reasons why we kind of course, need to test it. Of course, we tried already a lot of use cases, but I'm very sure since, I mean, the audience of all our customers and users are going to have a lot of different diverse applications and requests. So we want to, and we need to learn also based on your queries. So to see and see how the semantic or smart search can be applied to. And additionally, very important as well, it's not like that we discontinue the expert search or lexical search, as you've probably already seen, which we have discussed also in the white paper, but also if you've seen in the platform Scout, expert search and smart search, of course, are going to work in parallel. So if for few use cases, expert or lexical search works better, you of course can still use it, because for few use cases, it can be, of course, probably more relevant or better or, yeah, fitting. But again, we are very much looking forward to any feedback from you guys, and that's where our key account managers are here for.
We have two questions more. Yeah, sorry. One is, what is a good panel for measuring if the smart search understood my query as I mean it? In expert search, I have the query itself and can compare with the results. That's the first question we have. Peter, Matthias?
Hello, Matthias, if you have a quick question, answer to that. Otherwise, I'm thinking, since the smart search is gives you ranking based on the higher the result is, let's say if you talk about the publication, the more related and relevant it is, the less the threshold is. So kind of the later the result appears, of course, the less it's going to be relevant for your query. But there, in my opinion, there is no direct black and white 100% fitting or not fitting threshold or KPI or measurement possible. But probably I'm wrong. Matthias, you are more the expert here.
Okay. So first of all, the relevance score that you see in the publication panels, but also in other panels, is generally designed to measure how good the system thinks that it has, how good the system thinks the result matches to your query. Of course, the system could be wrong. So what you may be asking for is, which is the panel that allows me to check best for myself whether the user understood my query correctly? And the answer varies whether, for example, you're more familiar with what the relevant news are or the relevant research publications are. Whatever you're most familiar with is probably the best panel to check whether the system has interpreted your query correctly.
Thank you, Matthias.
One more question. Can MAPEGY only show the first 500 results for a given search topic? Looking at the results of a specific search topic, the research or patents tab shows 1 of 12 of 500 results.
Shall I or Matthias, you want to?
I mean, this is not related to semantic search or any other paradigm of the sort, but rather to user experience and the UI. So there should be a button where the user could switch from show me the first 12 results on one page, on the first page, but rather show me all of the results in one page. So I guess that would be a question for our product owner and or front-end developer, right?
Yeah, and there was the limit of 500 we have explicitly put in there because of also browser limitations, but Matthias is right. In the end, we have the data. More than 500, that's the explicit limit that we needed to have because of, again, the browser limitations. Through the API, of course, we could provide more publications, but I would say let's take it into consideration, and we're going to discuss it with our product owner, product manager, Ainhoa. Alessia, can you write it down just so that we
Yes.
kind of can get back to the person who just asked it?
Yes. So thank you so much. If there are not any other questions for now, you can always drop them in the chat at any time. So I'd say we can continue with the second case study. And yeah, as I said, if you have any questions, you can always drop them in the chat. And at the end of this presentation, we will get back to that. Thank you.
Shall I hand over to Christoph now, or how?
Yes, please.
Okay.
All right. So welcome, everyone. My name is Christoph Jenke, and I am the COO of MAPEGY. And what I would like to share with you are some insights that we gained through a research project MAPEGY is participating in. It is called KI for BoardNet and funded by the German Federal Ministry of Education and Research. And the project's German-English mashup name already hints at the German word Bordnetze, or in English, wiring systems. And what is meant here are new electrical or electronic EE architectures for the automotive industry. So the project aims to develop these architectures or components or design tools for the electrical vehicle system of the future. And partners of the research project include, for example, as you can see here, Carriot, the automotive software company of the Volkswagen Group, or Infineon, EDAG, and also like research institutions and universities like Fraunhofer, or universities like TU Dortmund or TU Dresden. And MAPEGY's role in this project mainly involves two topics. First of all, we are providing a comprehensive overview of the innovation and technological landscape. Of course, particularly in the research and development part of the future of vehicle electrical systems. And the second part is very closely related to our topic today, because what we are doing is we are doing research on natural language processing and large language models. And we are building a content collector and, of course, enhancing what you are seeing here today, which is the smart or semantic search. And this is why I think it's quite a good example to show you today to what semantic search can do. So to start, so when we task one of our innovation analysts with covering the topic of Bordnetze, he of course went, as most of us probably do, he went into desktop research and to get a general understanding of the topic. And that kind of meant, of course, not only first, just searching on desktop, but also doing expert interviews. So what he did, he reached out to all the professionals and experts from the companies participating in the project, and then he kind of tried to get all the specific terms and the industry-specific language of the product. And then he went, of course, into keyword development, as we all know, and then he kind of tried to, as a first step, to get precise and extensive set of keywords related to Bordnetze. So that would be like, as you can see here, EE, electronic architecture, it would be automotive wiring, and so on. And of course, then he kind of had to boil down that search. And what he did was he used, of course, MAPEGY Scout, and he developed a 2-layer Boolean search. What do I mean by this? So he combined the technical keywords with the more like automotive specific terms. So this would be a very simple example. So the first layer would be the technical keywords, and the second layer would be just, in this case, like automotive or automotive electrical systems and so on. And then, of course, he went to continue, and there were many iterations about this. He also structured it that he, as we mentioned before, so he had some not operators. So he had, I don't know, EE architectures and automotive and not marine, for example. So he kind of had a lot of iterations and tried to, cater to the needs of the different experts. And of course, throughout this process, he had to remain flexible and adjusting keywords and search parameters and kind of, trying to evolve the search. And as you all know, the precision of lexical search lies in the ability to really match the terms in the documents. And so then in the end, I think he had, we had a really nice portfolio. We had a really nice overview and project, and all the participants were really happy with the results, and they're using the product. And comparing this to the search, the smart search, of course, is very interesting now, because obviously, as we know, this has been quite a strenuous search. And when we look at the original project tender, it's EE architecture, as you can see here again. There are some just this keyword, and if we put that in as a very short comparison, if we put that into one of our into the smart search now, we are surprised how quickly we get results. We will, let me see, I did this already. So you will see that it really demonstrates the effectiveness in understanding the complex and context-driven relationships. There were a lot of extensive results, and actually, so here it was really interesting to see how you could, boil down a very complex topic into, very relevant results in a very short term. So this just very quickly, and maybe just comparing the results a bit again. So as Peter mentioned, there were in expert search and smart search, there were really relevant and also extensive results. So I think in this case, it's not about substituting one with the other, but it's really when we compare the two approaches, that they complement each other. So lexical search, as we found out in our case, is invaluable for targeting really specific information and ensuring that all the relevant technical aspects are covered. And in contrast, I think semantic search really excels in having a very comprehensive view of and understanding and having the broader context of a topic. So to summarize, in this use case, I think smart search is not necessarily better, but for sure the time to get to relevant results is like drastically reduced. So that will be my very short findings. Thank you for your attention, and let me know if you have any questions.
Thank you, Christoph. We have a few questions. First one, when can we expect the next update for the smart search, and what other updates can we expect? Peter?
Do you hear me? Do you hear me now?
Yes.
Since I was muted. Okay, perfect. Of course, our data team is continuously working on it. And as you can imagine, it's not like black and white, 1 week, 2 weeks or so. So it's, of course, we are working on it, improving it, and there's going to be continuous improvement. Point 1, point 2. This is why we also reach out to everybody. And that's why it's also labeled as better. Of course, we also need to get feedback from you, different use cases that we probably haven't thought about yet, so that we can learn. But again, build, measure, learn, there's going to be continuous improvement. Point 1. And point 2, we just talk about smart search for documents now. And I have a second or last agenda is like, what's next? MAPEGY product roadmap. I'm thinking of, since it's already 10:48 now, to jump directly to the MAPEGY product roadmap.
Exactly.
Okay, perfect. Again, we have prepared a white paper here. We have prepared more than 3 case studies, but for this webinar, we've prepared 3 case studies, and also in the white paper, these case studies are all described. Ashar also, he was in hospital. He prepared the case study 3 on hydrogen aircraft. He prepared also video. So we are going to happily share with you and send you over also all videos and all use cases later after the webinar, that's for sure. But let's skip it now. Sorry, Ashar, but thanks again for taking the time. So we are sick. I'm now, now Christoph is presenting the product roadmap already. Thank you, Christoph. Exactly. So currently we present also in the white paper, we only discuss smart search for documents. And of course, as you can imagine, and as I said already, we are going to expand from smart search to all other publication panels, but also to all other panels, which includes organizations, companies, startups, trends, and so on. That's what we call smart analytics. This is going to happen throughout the next weeks, months, and quarter. That's one big thing which we're very proud of. And of course, there's going to be a lot of testing. Besides that, of course, as you all already know, we have improved our alerts. We have alerts overview already. We have implemented the possibility that you can comment for or within any reports. If you have SSO for your enterprise, you can add already custom logos for, so it's not only written Scout or MAPEGY there, but also your company's logo if you want to share it externally as well. Of course, we are also going to have but we are also planning a integration with Microsoft Teams. But most importantly, we are also, because of the simplicity of smart search, the search is not going to be that present anymore in our new Scout, but we are going to focus more on the insights and tools and innovation related methods that you need to focus on. And I want to happily share with you and show you a glimpse into what we are currently developing with our new Scout look and user flow, so that you also see that there is not only a technical improvement in means of searching, but also the whole UX is going to change and improve a lot in means of simplicity. Let me take over, share. Here we go. So first of all, what you see right now, I hope you see Scout. You see, like I'm logged in now as a normal user. You see relevant fields and peers, partners overview are not available. If I go into the um, testing mode, you see even for my search granulate fabrication, I can also peers and partners, relevant fields and trends, they already work as well. But of course, we need to do heavy testing, and that's what the next step is going to be in means of smart analytics. That's point one. Point two is, as I said, this is now the mock-up. We're prototyping a lot of different ideas here, how the new Scout will look like. And again, that's with a grain of salt here. It's a lot of testing, but the idea definitely is to go from a horizontal to a vertical perspective with the menu, that we are going to have a dashboard, we are going to have topics, we are going to have organizations as we have it currently with our portfolio. We are going to offer a bookmarking. Talking about the topics and organizations, here you'll be able to rapidly and data-based identify and collect topics and organizations. First step. And the second step, you will be able to build up lists of bookmarks, lists of your trends, list of technologies, list of insights that are relevant, related to everything which you do in innovation intelligence, innovation management context. That's something which I think is very useful and very important. Of course, you're going to have also the report section where you can directly look at and share analytics regards to all your reports that you are producing. That's the content management system that you already know. And we are going to still, and that's kind of our core here as well, all the different innovation management or innovation intelligence related analytic tools like the portfolio, matrix, the radar, which are going to be aligned in the menu called tools or analytics. And last but not least, the newly developed improved alerts now, which are also going to have a very special space or place in our platform Scout. That's how the UX, how we are planning and envision the UX. Of course, there's going to be a lot of change, but as well, as I said, there's going to be quick, short improvement midterm, even at the latest next quarter already. So that's about that. Jumping back to my presentation. Are there any more specific questions relating also smart analytics or the new Scout UX or anything else? We have like 6 minutes to go. I was rushing through my last slides now. Hope it was not too fast, but I at least wanted to give you also a glimpse, an idea into what we are about to develop and implement in the near or short-term future.
Thank you, Peter. We have one question. When we will be able to save smart search results in the portfolio?
This is something which we are currently, which is a ticket which we are developing on. That's part of the whole smart search, smart analytics experience. When, I can't tell you exactly the week, but it's definitely going to happen this year, hopefully already in Q3.
Thank you. Any other questions? We got a very nice message from Team Kid. Thank you for that. We're really happy and proud. Thank you.
Thank you. I'm really blind. I don't see any chat here. So Alessia, you need to lead me. Are there any more questions, requests? Otherwise, I'm happy to conclude.
Not yet. We got a very nice feedback. Love the new smart search, dramatically increases the ease and speed to get to relevant results. Would like to see the results extended to the other areas such as peers and partners, and also would like to see the use of LLM AI to review, refine, and navigate the search results. Appreciate the build, measure, learn approach and mentality. We don't need a perfect solution, and we're happy to help make things better, more suitable for our user needs. So thank you for that.
Thank you. Again, to conclude, as you know, as I started, it was a lot of work, 3-4 years for our data team and a product team. And now it's this small feature, which is only represented by a box. And there's going to be way more to come. I'm very proud of our team that we have succeeded it as a CEO of the company, but I'm also very happy that you customers trust us and that you join us on this journey. And I promise there's going to be a lot more to come. So thank you again for everything. And again, if there are any specific requests that you have, please reach out to your individual key account managers who are there for you, who happily help you. We are looking forward to all your feedback, since only thus we can.
Peter, there's one last question.
Okay.
How complex should the smart searches be? Are there limits for now? For example, 2-3 sentences.
Oh, that's actually a question more to Matthias. In my opinion, the longer the search and the text that you put in, the more precise, of course, in my opinion, the results are going to be. But probably, Matthias, I would love to hand it over to you.
I don't know it from the top of my head, but the language model has a technical limitation in terms of number of tokens, which is basically number of words, which I think is around 250, which still leaves a lot of words. So technically, there's no limitation, no serious limitation. So you can enter 2 or 3 sentences if you wish.
And what is your experience, just top of your head, is the longer the query, the better, since then, of course, the match is going to be better, or what is your experience?
I think what you could do to improve results, which we are actually currently exploring to improve results automatically, is that you give a short explanation. So for example, you should get better results if instead of just entering pod drive, you would enter pod drive is a propulsion method for marine vessels, and then search that phrase instead of just pod drive. I think this should consistently give better results.
I agree. That was also one of my experience with my use case, for example, for fused granulate fabrication. Once I put in fused granular fabrication for 3D printing, then it was even more precise. Of course, the recall was lower, but of course, the precision was way better. And the results, of course, were also way better. So that's the good about it. I just type in what I think, what I feel, and what I need. I don't need to have any lexical or Boolean searches anymore, which are, of course, way more limited. Okay, it's 10:59. Thanks, everyone, the team, as well as all you who joined us today. There's more to come. It's said, looking forward to the collaboration, and have a lovely, today is Wednesday, right? Yeah, have a lovely Wednesday.